Hello everyone, welcome to this channel and welcome to our series on strength of materials. We are looking at moment of inertia of an area using the parallel axis theorem. Kindly subscribe, like, share, leave your comments and suggestions as well. Good, quickly let's look at our question and how to solve it. Determine the moment of inertia and the radius of gyration of the shaded area with respect to the x-axis. And this is a diagram you have been given. Let's see how to solve it quickly. Good. So this is our structure which we have, and we have been asked to determine the moment of inertia. The moment of inertia is always determined with respect to a specific axis. So you can be asked to determine the moment of inertia with respect to the x-axis, or with respect to the y-axis. So take note of that. And when you are asked to, in this case, you are asked to determine the moment of inertia with respect to x-axis. So the x-axis will only be our focus. Therefore, this x-axis is going to be our center or the centroidal axis. So what we are going to do is to divide our section into our structure into sections. So we can take the first section to be this whole structure here can be our first section. Let me change it, the color. So this is going to be our first section. So we can call it section 1. Then we can pick the whole of this. So the whole of this is going to be our second section. So always divide it into smaller sections, which you know the formula to calculate the moment of inertia. We have already seen that the formula for calculating the moment of inertia of a rectangle. So we can divide our complex structure into small areas, which we can easily determine their moment of inertia. So what you do is that once you divide it into sections, you find the area of each of the sections, so that the total area of the entire structure is going to be area 1 plus area of section 2 plus area of section 3. Take note. If it was a composite structure where some portion is cut out, then the area is going to be negative. So for example, if I have a structure like this and the center is cut off, then if I make the outside as my area 1 and this is as my area 2, because this is cut off, the area is going to be negative. Take note of that. So I determine area 1. So from area 1, portion 1 is a rectangle, and the area will be length times breadth, and that will be equal to, from here, the length will be 16 plus 16, which will be 32, times the breadth, which is 8. And from there, the area is going to be 256 millimeter raised to the power 2. We can determine the area for side 2. The area for side 2 is, we can see that the length is 10, the breadth is 28 plus 28. This whole thing is area 2. So the length is 10, so we can get 10 times the width, which is 28 times 28, which will give us 56. So from there, our area is going to be 480 millimeters squared. Then we can determine area for the third section. The length is 30 plus 30, which is 60. It is also a rectangle, so length and breadth, and the width is 8. And from there, area 3 is going to be 60 times 3, which is 400. Sorry, the 56 times 10 is supposed to be 560. It's supposed to be 560. Sorry for that. It's supposed to be 560. And this one is supposed to be 480 millimeters squared. And from there, our total area is going to be 256 plus 560 plus 480 is equal to 1520 millimeter squared. Then, once you are done with that, we can determine our moment of inertia. So the total moment of inertia with respect to the x-axis, total moment of inertia of area, not moment of inertia alone. We have moment of inertia of mass, but what we are doing is moment of inertia of an area, or the second moment of area will be equal to the second moment of area for the first section plus that of the second section, section 2, plus that of the third section, which is section 3. So we need to determine the moment of inertia for each of the parts separately. Now let's consider section 1. When we consider section 1, you can see that this is the x-axis. And the x-axis, we are asked to determine with respect to the x-axis. Now the x-axis, we are going to take the x-axis as our centroid. And you can see that the x-axis only passes through section 2. It doesn't pass through section 1, and it doesn't pass through section 3. So it means that section 1 is going to have its own center here, its own centroid, somewhere here. This is the center with respect to the x-axis. And section 3 is also going to have its own center somewhere here. However, section 2, the center is where the s is passing through. Good. So when we have that, because the center of this section 1 is not this centroidal axis, which is the x-axis, is not passing through the center of section 1 and section 3. And section 1 and section 3 have their own centroid. So to determine the moment of inertia with respect to the x-axis, we use the parallel axis theorem. And from the parallel axis theorem, Ix for section 1 is going to be the moment of inertia of section 1 when it has its own centroid as this. When it has its own centroid as this, will be given by this plus the area of section 1 times the square of the distance between the centroid of section 1 and the centroidal axis, which is from this point to that point. So we call it d squared. So from moment of inertia formulas, we said that the formula for finding the moment of inertia of a rectangle about its own centroid is 1/12 dh cubed, so plus the ad squared. So from here, we know from the formula that the base of the rectangle is 32, 16 plus 16, and the height is 8. And the area which we calculated is 256 times the distance between this x-axis we are determining the moment of area from, and the centroid of that section. So from this to that is 28. But the center of this area, let me clean so that you can see clearly. This whole thing is 8. So from this to that, the center is going to be 4. Center is going to be 4. If you want the distance from the center here to the axis, which is, you can see that this is parallel. The centroid of this section is parallel to the x-axis. So that's why we call it the parallel axis theorem. So from here, you can see that the distance between these two parallel axes, which is the centroid of section 1 and the centroidal axis of the whole structure, which is on the x-axis, is 4 plus 28, and that is going to be 32. So 256 times 32 squared. And from there, when you do the math, we are going to get it to be 263,509.3 millimeter raised to the power 4. Good. Then we come to section 2. Section 2, the centroid is passing through there, so we are not going to use the parallel axis theorem. So we just use this formula, the formula for finding the moment of area for The formula will find the moment of area for a rectangle. That is also a rectangle. So the formula is BH cubed. Don't forget that we said that moment of inertia of area measures the ability of a bar or a beam to deflect or to bend. That is what is the measure of. So from here, we are going to get it to be 1/12. This is 10. And the height is 28. So from there, we are going to get everything to 18293.3. And we have gotten for session 2. And we do for the last session, which is session 3. This center is also away from the centroid of the whole structure is not passing through that section. So it means that the axis is like this, and this axis, because this centroid is not passing through the x-axis, we use the parallel axis theorem. So for section 3, the parallel axis theorem, Ix for that will be equal to BH 1/12 BH cubed plus AB squared. And from there, its base is 30 plus 30, which is 60, and its height, which is 8 cubed, which is 8 cubed, plus the area of that side. So the area was 480. The area of that section is 480. And the square of the distance between this centroid and the centroid of the whole structure, which is the x-axis. So because they are parallel, this is 28 and this is 8. So the center, the length of the whole structure is 8. So it means that the center will be at 4. So this is 4. And we have 4 plus 28 to be 32. So we have 32 squared. And from there, everything will be equal to 4080 millimeter raised to the power 4. Yes, millimeter raised to the power 4. Then from there, we said that the total is going to be for 1 plus 2 plus section 3. So we add all the areas together. And from there, you put area for section 1, area for section 2, and area for section 3 all together. You put all of them together. And once you are able to do that, we are going to find out that the total area, the total moment of inertia for the entire structure will be equal to Ix1 plus Ix2, moment of area of the second section, plus moment of area of the third section, which you have calculated. And from there, the total is going to be 77575882.6 millimeter raised to the power 4. And from there, we are asked to calculate the radius of gyration. We know that Ks squared, the radius of gyration K, times the area is equal to Is. Ix. And Ix is here. We know the total area. This is the total area of the structure. So Kx will be equal to the square root of Is over the total area. And we know Ix is what you have calculated, which is 775882.6 over area, which is the total area, which is 1520. And from there, the radius of gyration will be equal to 22.6 millimeters. And this brings us to the end of our course for today. Finally, if you have anything which you don't understand, you can let us know, and we'll be more than happy to assist you in understanding the concept which has been discussed on the platform here. So once again, thank you for keeping in touch. Kindly subscribe, like, share, and hit the notification bell as well. We meet again in our next video. Until then, bye-bye.